This instructional video will show you how to find the standard cell potential when given a voltaic cell written in cell notation. The first step is to read this and complete the half cell reactions as given. So we have solid copper going to copper 2 plus, and on the reduction half we have the dichromate ion going to chromium 3 plus. And we would use the steps in the redox half reaction balance method to complete this. So the only thing we have to do here is add in 2 electrons so that both sides have the same charge and the same number and type of atoms. In this case, we're going to have to balance the chromium. Then we're going to balance our oxygens. We need 7 waters. This is 14 hydrogens. And the only thing remaining then is to balance out the charge. And we have plus 6 here. We need to add in 6 electrons so that the charge is the same on both sides. So now that we have our balanced half reactions, the next thing we want to do is to write these both as reduction so that we can find them in a lookup table. So here we have copper 2 plus our 2 electrons, yielding our solid copper. And if we go to a table, we find that the E cell standard for this written as reduction is positive 0.34 volts. Next, this one is already written as a reduction reaction, so we simply need to write it all out, and we'll find this reaction in a table as well. Dichromate 2 chromium 3 plus and 7 waters. And so the E cell for this half reaction, when we look it up, is positive 1.33 volts. So the final step then is that the E cell overall is going to be equal to the standard reduction potential of the cathode minus the standard reduction potential of the anode. And so in this case we can substitute in these values. 1.33 minus 0.34. And so the E cell standard for this reaction as written is 0.99 volts. And because the E cell standard is positive, the other thing we know is that this is spontaneous as written. So this is how we can determine a standard cell potential starting from our cell notation.